What is the binary equivalent to decimal number 297? Remember, binary is just a base 2 number. Base 2 numbers are numbers that computers like that use only the digits 0 and 1. Our number system that we traditionally use, base 10, uses digits 0 through 9. Something else that's a little bit different, our number system increases its place value by a multiple of 10. The base 2 number system increases their place values by a multiple of 2. So you still start the same way when you build the place value for base 2. Instead of increasing by a multiple of 10, you increase by a multiple of 2. But you still start at the ones place. Increase by a multiple of 2, so 1 times 2 is 2. The next one is 2 times 2 gives you 4. 4 times 2 gives you 8. 8 times 2 gives you 16. 16 times 2 will give you 32. 32 times 2 gives you 64. 64 times 2 will give you 128. 128 times 2 gives you 256. 256 times 2 gives you 512. And then 512 times 2 gives you 1024. And you could keep going. Now this is very similar to base 10. It's just the difference is instead of multiplying by 10, we're multiplying by 2. But the idea of how a place value system is built is the same. Now, the next thing you're going to do is you're going to take the traditional number that's in base 10, and we're going to turn it into a binary number that the computer will read. So 297, and the first thing you're going to do is to figure out which one of these place values is the biggest, is as close as you can get to it without going over. So 512 actually goes over 297, so we can't use that one. But the biggest one I could use without going over is 256. So I'll put a 1 here to represent a yes. We can use 256. So now we take the 297, we subtract 256 from it. 7 subtract 6 is 1, 9 subtract 5 is 4, 2 subtract 2. So we're left with 41. So now you start the problem over again. If you only have 41, which one of these numbers up here is the closest we can get to it without going over? Well, 128 is too big, so we put a 0 to represent no. 64 is too big, it goes over, so we represent a no. But 32 is as close as we can get, and we put a yes there, a 1 representing a yes, and we can actually subtract that out. So we carry out our subtraction again. 11 subtract 2 gives me 9. 3 subtract 3 gives me nothing. So I'm left with 9. We start the problem over again. You go back up here. 16 is too big, so we put no. 8 is just right. It gets really close to it without going over. So we will say yes to that. Put a 1 to represent a yes, and then just carry out your subtraction. 9 subtract 8 is 1. And we start the problem over again. We're left with 1. You go up here, you look at 4. 4 is close to it, but it's too big, so we put a no. 2 is too big, so we put a no. And a 1 is just right, so we put a yes, and we put 1. And we subtract, and we're left with the remainder of 0. So the binary equivalent to 297 is the digits 1, 0, 0, 1, 0, 1, 0, 0, 1. It should match with this down here.